eet105, Chapter 12, Section 12, Determining Phi. So you're in the example, determine the magnetic flux Phi established in the series magnetic circuit shown below. So you're given the current, 2 amps. You're given the number of turns, 150. And you're given the various lengths around this circuit. You're given that it's cast steel. So the distance between C and D would be this gap. 8 times 10 to the negative 4 meters. Then length AB equals the length BE. Okay. Equals the length of EF equals the length of F to A. So this is a square. Okay. That's really all that's saying. Equals 0.2 meters. And then the area throughout, it's a continuous uniform area equals 2 times 10 to the negative 4th meter squared. And then the length from BC is equal to length from DE. So you have to figure out again what those lengths are. So we use our standard equation. Since it's one, this is the equation here. So this is the force going in, N times I, which we know what both of those are, equals H, H of AB. And they're just saying H of AB because it's a uniform H throughout this material, okay? And then you have to sum up the lengths of each part of this cast steel section. So when you do that, and then you add in the H of the gap times the length of the gap. So 2 times 150 is 300, and then H, and then when you add up all these lengths, you have to figure out what these two are. You get 0.8 meters. This would be this length plus this length plus this length plus this length plus this length. It's 0.8 meters. And then H of air is going to be Bg divided by mu 0, which is 7.97 times 10 to the 5th times Bg. So here's the times the length of the gap. Here's the big thing here. So you have two variables in one equation, which is an odd thing. It's not like you can solve because you only have one equation. So what they did here was they assumed that this term is much greater than, that's what this double greater than means, much greater than this term. So then if this term's much greater than this term, basically you can say this is 0. And then then he took that 300 equals 637.6 times Bg. Bg equals 0.47 Teslas. So then phi, because that's what you're being asked to find, is B times A. Is that 0.7 times 10, 2 times 10 to the negative 4th, which you're given. Where was it? Right here. And then A equals 0.94 times 10 to the negative 4th Webers. So then BAB equals BG equals 0.47. So then from figure 12.8, you're given for cast steel 0.47 Teslas. Cast steel 0.47 Teslas is about right here. So that'd be what, like 280 or so for your value of H. They said, what did they say? 270. So when you plug that back in, this value of H, you plug that back in to your equation where you made your assumption, this then equation. So 300 equals 270, or no, you plug it back in the original equation right here. 270 times 0.8 times 637 times 0.47, and you get, they're saying these numbers aren't close enough together. So then what they did was take that number and divide it by this number, 58%, and reduce phi to 58% of the value that you calculated and knock it down to here. Because you want these things to be equivalent. Okay? So that's what they did. They're making another approximation. So B is equal to the new value of phi divided by A is 0.2 Teslas. And then when you go to the figure 12.8 again, you get H of 190. So then you plug that in your equation and you get 300 equals 330. So then what they're saying is take that 300 or the 330, 300 divided by 330 times 100% is about a 10% difference. So you reduce phi, you do another iteration, you reduce phi another 10%, and you get phi equal to 0.495. You plug that back in, get an H value again of 175, and then take 300 times 1. You plug it back into this equation here, right here. So you take 300 equals 1.75 times 0.8 times 637.6 times 0.28. Excuse me. And I'm not real sure where they got that 0.2. I think it should be point there. They did this 0.28. So then they said when you do that, 300 is not equal to 318, but it's a lot closer. It's within 5%. They said, okay. So then phi, your estimate of phi, 0.55 was okay. So that's basically how you do it. The weird thing about this is that you figure this equation out and then you have to start doing estimation.